Hi, welcome back to Mr. Slover's Math. Today we're going to focus on solving inequalities with like terms. So this is just a warm-up up here to get us thinking about what like terms are and how to solve. So over here we've got m and 2m. I've highlighted my like terms. Same variable, same power, so that gives me 3 of them. Plus 4 equals negative 11. So I'm subtracting 4 from each side and then dividing by 3. I get m is negative 5. Letter B is similar solving. You may be thinking, well, why do we need to practice solving equations if we're solving inequalities? Remember, you solve an inequality just like you do an equation. There's just that one step, and that's what this is down here, letter D. When solving inequalities and you multiply or divide by a negative, you have to flip or switch the symbol. So here we go. We're going to get through example 1. Here's just something that might help as we work through the problems. So solve the following inequalities and graph. Work is required. So we're going to imagine that this is really saying x plus 4 equals 9. So in order to solve that, we would have to subtract 4. Well, we're going to do the same thing with inequalities. We imagine that it is an equation, and we solve just like we would an equation. So we subtract 4 from both sides. We have the variable isolated, and it's all by itself. So x is greater than 5. So I put 0 on there as my reference point. My positive numbers are to the right of 0. My negative numbers are to the left of 0. So since it's positive, it's going to the right. It is an open circle. It just says greater than. And because my variable is on the left, whichever way this symbol is pointing, it looks like it's pointing to the right. My arrow goes to the right. So what this is saying, this is my solution set. Any number that's bigger than 5, so anything larger than 5, 5.1, 5.2, 10, 1001, any of those and more, if I substitute that in, it makes it a true statement. Letter B says negative x is less than or equal to negative 15. Well, we've seen this before. Negative x is really saying negative 1 times x. So to undo that multiplication, we need to divide. So we're dividing both sides by negative 1. But notice in red over here, I said we divided by a negative, so we got to flip that sign. So it went from less than or equal to greater than or equal to. So when I graph my solution set, I am on the left-hand side of 0 because it's negative. My circle is filled in, and my arrow is going to the right this time. So anything that is negative 15 or greater, so I'm including negative 15 because my circle is filled in. Anything that's negative 15 or greater, and I substitute that in, it would make it a true statement. Example 2 is just some more problems to work through. So now we're moving into two-step inequalities, but we think of it as two-step equations. Okay, so I do want to look at letter C. If you notice, this is the only one on this example that is highlighted. Well, that's because I have like terms. Negative 8w plus 2w. They're on the same side of the inequality symbol, so I can combine them together. Negative 8 plus 2 gives me negative 6. So I have negative 6w is less than or equal to 28. I divide both sides by negative 6. But notice in red over here, I had to flip that sign because I divided by a negative. And it's okay that I got a fraction. If you turned it into a decimal, negative 4.67 or negative 4.7, that's fine. I just left it as a mixed number. So you can work through the rest of these. If you have any questions, let me know. The big takeaway is to make sure that if you are